Fine. Like shukar hai. Okay, are you getting my voice, beta?
Yes, sir. Loud and clear.
Okay. So today we are going to discuss about the entropy as a state function. ठीक है बेटा. So एक second बेटा. एक second. Just. So entropy as a state function what does mean by the state function? We discussed in the previous lecture. What does mean by the state function? Anyone can tell me? Can anyone tell me?
Independent of path.
तो पाथ पे डिपेंड ना करे इंट्रिंसिक प्रॉपर्टी
बिल्कुल बिल्कुल it is path independent and it only depends on the initial and the final state. It doesn't matter how it reaches to the final state. Let's suppose if you are traveling from A to B, whether you have traveled in a zigzag manner or you have traveled in the straight way or you have traveled in the circular way, the only thing that matters is that at what point do you have reached, whether you started from the A and you reached up to the B point. In between, no, it doesn't matter what path you have followed. Okay, so it is path independent. It only depends on the initial and the final state. Okay, so कहते हैं कि in this case we will drive a mathematical equation that will allow us मतलब by experimentation that will shows that it is path independent. ठीक है जी. और by experimentations we have observed certain things that shows that entropy is path independent and furthermore it only depends on the initial and the final state. Okay, so कहता है कि in order to make the process reversible, ठीक है, एक second बेटा, still there are students coming on. Okay, and then there will be no further admittance of the students. Okay, so how कहता है कि we can prove it is a state function for the special and important case in which the ideal gas is taken through a reversible process. ठीक है, so for that purpose what we will do is कि in the reversible process we will take the small steps. Okay, in each and every steps we will say that there is a small मतलब incremental change in the system. ठीक है, incremental change means कि very small change, it very small change so that the equilibrium of the system does not disturb. ठीक है, if you will change, there will be macroscopic change, so obviously the equilibrium of the system does not be maintained for a small time. Okay, so after some time it will get maintained, but in any instant it will not be maintained. So for that purpose what we are doing is that we are changing the system conditions in a very small steps. Okay, let's suppose if you have a second beta. Just hold on a second. So this is the step A, okay, and this is the step B here. Okay, so in normal case what does happen? Okay, the system goes from A to B point. It doesn't matter whether it goes in a very fast conditions or it goes in a small steps. Okay, usually we prefer that we have changed the system in a very incremental way so that the equilibrium of the system can be maintained. So there are chances that if you are moving the cylinder in the upward direction, okay, it can go suddenly to the final condition. But again, in the case of the reversible process and in the case, in order to observe the equilibrium, it should be taken in the small steps. Okay, like here. Okay, we have what happened that when the system goes from A to this point, then what will happen that system is goes from this to this point means that we are changing the system in a very small step. So as a result, the equilibrium remains same, matlab maintained during the whole process when the body goes from point A to point B here. Okay, even you already have studied it. Okay, whenever you there is expansion or the isothermal process or the isoporic process, they usually recommend, okay, you will move the piston in the upper direction in a very slow manner. So why you need in a very slow manner, so that the change equilibrium can be maintained in a system when the body goes from the step 1 to step 2, then step 2 to step 3, and in the overall from A to B overall the equilibrium can be maintained. Okay, up to this point, any question? Okay, I think यार आवाज आ रही है आप लोगों को मेरी?
Yes, sir.
Yes, sir.
Still, then fine. Okay, so in the next stage क्या है कि we will use the first law of thermodynamics. Okay, the amount of energy, मतलब हम लोग कह लेते हैं कि okay जी हमारे पास just hold on a second, कि हमारे पास ये step था, ठीक है, this was the A point as I was telling you. Okay, so we moved from point A to this point. Okay, so this is a small step. So for this small step, the energy transferred is dq. Okay, so they have mentioned here the energy transferred from point A to this step is dq. Okay, the work done by the gas would be obviously dw, and the change in the internal energy would be d. So using the first law of thermodynamics, we will get this relation. Okay, this is the first law of thermodynamics. So d internal is equal to what? dq minus dw. So dq can be written as, कैसे लिखा जाएगा? dq can be written as, obviously we will take dw on the other side. So d internal energy plus dw is equal to dq. So this would be the relation. Just hold on a second. It would be just, we rearranged it. So dq would be equal to de plus, एक second, plus dw. So this relation would be like this one. Okay, so we will just put the values of internal energy and that of the work, and as a result what will happen that we will get this value here. So what is the value of the work for this small step? It is pdv. So we know that W is equal to PV, ठीक है, PV. So in a small step, yeah, for this small step, dW would be equal to PdV, and while the internal energy, as we have studied in the previous case, that it would be equal to NCV dt, ठीक है, where the, by putting these two values into this equation in the above equation which I have written here, so dE will be equal to NCV dt plus PdV. Okay, so here what they have done is, okay, they have replaced the P with the nRT hour. P किसके बराबर था? PV obviously is equal to nRT, ठीक है. So P would be equal to nRT by V. Okay, so putting this equation, putting these values, कहाँ पे पुट करेंगे हम लोग? ऑब्वियसली इस इक्वेशन के अंदर पुट करेंगे. एक सेकेंड. So putting the value of P into the above equation, we will get Okay, so up to this point, this equation would be like this one here. ठीक है बेटा? So at this point, what we will do is okay, we will divide each term with the t. ठीक है? When we will divide it, क्या होगा हमारे पास? Obviously, या आप ये कह सकते हैं we will take t common. ठीक है? So relation would be like this one. अगर मैं divide कर देता हूँ, या चलो t common ही ले लेते हैं. यार बेटा ये जो है एडमिट करने वाले बार बार आ रहे हैं. अब मैं कितनी दफा बेटा एडमिट करूं? जो आपकी टाइमिंग है यू शुड फॉलो दैट टाइमिंग रादर देन कमिंग एट मतलब 120. नो दे आर कमिंग बाय एंड मतलब आई एम राइटिंग समथिंग एंड दे आर just coming by and I have to meet each and every of them. Next time I am not going to take any student after 1-5. Is it clear beta? And I will make sure that I will turn off. ठीक है screen. यार ये तो कोई तरीका ना हुआ कि अभी तक एडमिट हो रहे हैं सारे. फिर वही काम है यार. Okay, so the relation would be something like this one. So t will go in the denominator on the left side. ठीक है, dq by dt. This equation would be like this one. And our dv over v is equal to ncv dt over t. So is it clear up to this point, beta?
Yes, sir.
Yes, sir.
Okay. Okay, so this is how they got the relation to this point. So in the next step, what they have done is, so this is the change in the heat or the change in the system for a small step, very small step. Okay, your first step, it is this is the change. Okay, so when you have to apply for the whole path, so that you can go from the point A to point B. So for that purpose, what you will do is that you will apply the एक second beta. You will apply the limits there. Okay, so integrate, we will use the integral, and then from I to I, from initial stage to the final stage, the relation would be obviously we are integrating this both sides for the initial stage to the final stage. So this relation will be something like this one. Okay, the volume change from initial stage to the final stage, temperatures change from the initial stage to the final stage. Okay, so the change in entropy would be equal to, okay, delta S is equal to this relation. So this is the relation, final relation for the change in the entropy. Okay, and here you can see that it depends only the properties on the initial states and that of the final state. It does not depend upon the properties or the path, how the sorry, on the path between them or how these properties are changed. Okay, so this equation shows that entropy is a state property. Okay, clear up to this point? Any question, beta? Chale. So moving toward the sample problem. So this is the sample problem here. It shows two blocks. Okay, one is the L and other is the so L means left here, R means right here. So L is at higher temperature compared to the thermal reservoir. R is at lower temperature compared to the thermal reservoir. Okay. How I do know this, that you can see here in the left block, the energy is transferring from the block to the thermal reservoir here. While in the case of the right block, the energy is transferring from the Q to from the thermal reservoir to the block here. Okay, so this shows that the both are the identical blocks and both have the masses of 1.5 kg. So while block L is at 60 degrees centigrade, and again you can see that it is at high temperature, while the block R right block is at 20 degrees centigrade. The blocks are thermally insulated and are separated by insulator shutter. Okay, there is an insulator shutter here somewhere. So when the we lift the shutter, so what will happen that the block eventually comes to an equilibrium temperature 40 degrees centigrade. What is the net entropy change of two block systems during the this irreversible process? Acha, did you get the question? K
No.
obviously.
No, sir.
अच्छा आपको क्वेश्चन ये था कि टू ब्लॉक्स हैं, मतलब ये तो समझ में आ गई ना कि टू ब्लॉक्स हैं, वन इज एट हाई टेम्परेचर, अदर इज एट लो टेम्परेचर, ठीक है.
Yes.
इन वन केस मतलब इन ऑर्डर टू इन वन केस क्या होगा कि इट इज एट हाई टेम्परेचर, इट इज इन द फर्स्ट केस. सो ऑब्वियसली क्या है कि एनर्जी विल ट्रांसफर फ्रॉम द ब्लॉक टुवर्ड द thermal reservoir, because thermal reservoir is at low temperature. In this case, what is happening that block is at low temperature compared to the thermal reservoir. So when we will open the shutter, the energy will transfer from the reservoir to the block. In both cases, the body will come, both will come at equilibrium. At equilibrium, and the equilibrium temperature is the 40 degrees centigrade. So he want us to find out the change in the entropy. Okay, what would be the change in the entropy? So this is what he is asking here. Okay. So एक second बेटा. एक second बेटा. कहता कि सेकंड बेटा, स्टिल एडमिट वाले आ रहे हैं, अब पता नहीं इनकी ड्रॉप हो रही है या क्या हो रहा है.
सर वो कुछ बच्चों के ना नेट प्रॉब्लम है, तो इस वजह से वो कह रहे हैं.
सर आप ऐसा करें कि आप
मैडम,
किसी और को परमिशन दे दें तो आप क्लास पढ़ाएं, तो वो ऐड करता जाएगा.
एक सेकंड बेटा, मैं क्योंकि बार बार वही एडमिट कर रहा हूँ, वो थोड़ा सा मुझे प्रॉब्लम हो रही है. एक सेकंड बेटा. नहीं बेटा, आप लोग एडमिट नहीं कर सकते. चलो अच्छा, इन दिस सिनेरियो व्हाट इज हैपनिंग, मतलब इस केस के अंदर क्या है कि आपका टेम्परेचर चेंज हो रहा है. इट इज चेंजिंग फ्रॉम इनिशियल टेम्परेचर फॉर द लेफ्ट ब्लॉक. इट इज फॉर मतलब एक सेकंड बेटा. For this block, the temperature of the block was 60 degrees, मतलब 60 डिग्री सेंटीग्रेड. एंड while क्या था कि आपके पास इस केस में ब्लॉक का टेम्परेचर क्या है, 20 डिग्री सेंटीग्रेड है. So after some time it will come into the equilibrium. So in both cases, equilibrium में कहाँ पे 40 डिग्री सेंटीग्रेड पे. In both cases what is happening that the final temperature is 40 degrees centigrade, but in one case uh, heat is getting out of the system, in the other case heat is getting into the system, into the copper block. So for the left reservoir we will use the relation, okay, and this is the relation, and you can see here that the only variable here is the change in the temperature here. So this relation will be written as like this one, I मतलब initial stage to the final stage dq over t. So dq can be written as एनर्जी को हम लोग कैसे लिख सकते हैं, 18 चैप्टर में हम लोगों ने किया था कि आपके पास क्या है, ये किसके बराबर हो सकती है, एम सी टी के बराबर, डेल्टा टी के, बट हियर वी आर चेंजिंग डिफरेंशियल चेंज, सो इट वुड बी इक्वल टू एम सी डी टी. सो this relation would be something like this one. Okay, these both quantities are constant. ठीक है जी, this is the specific heat, c is the specific heat, m is the mass, and both are constant. So the only variable here we are getting again is t here. So we will integrate it with respect to this one, and the relation would be this one by putting the values. क्या है अब आपके पास tf फाइनल टेम्परेचर आपके पास कितना है, आपके पास फाइनल टेम्परेचर इट इज 40 degree centigrade. So 273 plus 40, it would be equal to 313. So initial temperature for the left block was 60 degree centigrade. So आपके पास 273 plus 60, it would be equal to 333 Kelvin. ठीक है? So you will put these values here, and the final answer would be this one for the change in entropy for the left block. So then we will move toward the right block. So again the same equation will hold by, but here in this equation, no, the only change here it would be the temperature. The final temperature for this one, again it would be 313 Kelvin, but the initial temperature here in this case was 20 degrees centigrade. So 273 plus 20, it would be equal to 293 Kelvin. So you will write it as like this one, you will put the value, and finally the net entropy change of two block system will be written as like this one, ठीक है, delta s plus delta r, and it would be like this one here. Okay, अच्छा अब again एक चीज जो इन्होंने मिस की है, कहाँ पे चले गए, एक सेकंड, जो चीज कंफ्यूजिंग हो सकती है हमारे पास, नो डेट इज दिस वन है, एक सेकंड एक सेकंड अच्छा इन्होंने कंफ्यूजिंग नहीं की, मेरा ख्याल है मैंने कंफ्यूजिंग कर दी है बेटा. बेसिकली इट वाज समथिंग लाइक दिस वन, ठीक है, ये था बेटा, ये इन्होंने रिवर्सेबल बनाने के लिए किया है. ये फिगर नहीं बेटा, आपके पास ये फिगर है. मैं वो थोड़ा सा हो गया था कि हम लोग why we are getting negative entropy here for this process, it should not be negative. ठीक है, for मतलब if we are dealing with the same मतलब जो है सिस्टम के अंदर, तो ये बेसिकली उन्होंने इंडिविजुअल यहाँ पे कैलकुलेट कर लिया, बट ओवरऑल नेट फॉर दिस सिस्टम इट वुड बी पॉजिटिव. ठीक है, सो एनी प्रॉब्लम अप टू दिस पॉइंट, सैंपल प्रॉब्लम क्लियर हुई है या मैं शुड आई रिपीट इट?
सर जी
एनी क्वेश्चन? या सिर्फ ये याद रखना है, जो मेरी तरफ से प्रॉब्लम आई है, मैं उस फिगर को देख रहा था. यू विल रिमूव दिस शटर, ठीक है, लेफ्ट है राइट है, यू विल रिमूव दिस शटर. ठीक है, द प्रोसेस विल गो फ्रॉम दिस पॉइंट टू दिस पॉइंट. दिस इज इरिवर्सिबल प्रोसेस. अब वो जो प्रोसेस है जो ऊपर दिया हुआ फिगर 26 में, दैट इज इन केस के अगर इफ यू आर डीलिंग विद द रिवर्सिबल प्रोसेस. ठीक है, सो व्हाई इट इज इरिवर्सिबल, अब आप सेपरेट कर सकते हैं इनको, टू चैम्बर्स को डिफरेंट टेम्परेचर के ऊपर, अगर आपको कहा जाए, कैन यू ब्रिंग इट टू द इनिशियल स्टेज once they are in equilibrium? नहीं कर सकते आप,
नो सर, इसको नहीं कर सकते।
नहीं कर सकते, ठीक है। अगर करना भी होगा तो देन यू, अगर आप करना चाह रहे हैं तो इट शुड बी लाइक दिस वन है, कि आपकी जो सिस्टम है इट शुड बी लाइक दिस वन, ठीक है। लेकिन फॉर दिस सिस्टम इट वुड बी डिफिकल्ट, डिफिकल्ट क्या है, ऑलमोस्ट इम्पॉसिबल है यहाँ पे। सो दिस इज इरिवर्सिबल, द नेट एंट्रोपी फॉर दिस सिस्टम, सो दिस सिस्टम गोज फ्रॉम दिस स्टेज टू दिस स्टेज, इट इज 2.4 जूल पर केल्विन, ठीक है, which is a positive entropy, change in entropy, okay। So in the same way in the next scenario, टाइम खत्म होने वाला है, कितने मिनट्स रह गए हैं?
सर 5 मिनट है।
5 मिनट रहते हैं।
बस ठीक है, ये कर लेते हैं। आजकल आपकी टाइमिंग क्या है रमजान में?
सर वही सुबह 8 से 4।
नहीं, यूनिवर्सिटी नोटिफिकेशन के मुताबिक तो 10 से 4 है आप।
सर वो ऑफिस टाइमिंग्स हैं।
अच्छा, नहीं लेक्चर्स का भी इसी तरह का ही है।
सर अभी तक
लेकिन
तो
चलो
वो
हमारे पास पे प्लान नहीं
स्टार्ट
आया।
नहीं हुआ।
चलो फिर अच्छी बात है, 8 से 4 ही।
सर नेक्स्ट वीक से
क्यों
कह रहे थे
मुश्किल-
हो सकता है कि 10 से 4 का कर दें।
अच्छा, नहीं वैसे 10 से 4 ही है आपकी एक्चुअल में। मेरी क्लास वही बनती है, एक 20 से 2 तक है शायद, या एक 20 से लेके 2 तक है शायद। 40 मिनट्स की क्लास ऑलमोस्ट हो गई है, और मैंने नोटिफिकेशन नहीं देखा, बट इट वाज लाइक दैट, ओके। अच्छा, अब इन दिस प्रॉब्लम he is asking about, suppose 1 mole of nitrogen gas is confined to the left side of the container, ठीक है, फिगर 21A बहुत पीछे है। You open the stopcock and the volume of the gas doubles, what is the entropy change? अब जो आप लोग वो पढ़ रहे हैं stopcock वाली, याद है आपको एग्जाम्पल या नहीं याद?
सही याद है।
अब मैं फॉर द सेक ऑफ, चलो मैं बता देता हूँ आपको। फ्री एक्सपेंशन जब पढ़ रहे थे हम लोग, दिस इज द स्टॉप कॉक वाली एग्जांपल।
यस सर याद है।
Gas is confined on the left side, and then on the right side there is vacuum chamber. There is a stopcock between them. When you will open it, the volume of the gas will get doubled. So this is what he's telling us, that when you open the stopcock, the volume of the gas doubles. What is the entropy change? Okay, we have to find out the entropy change. Again, अब इन द लास्ट सिनेरियो, जो लास्ट स्टेट प्रॉपर्टी हमने पढ़ी थी, तो हम लोगों ने क्या यूज की थी? चेंज इन एंट्रोपी, दिस वुड बी समथिंग लाइक दिस वन, ओके। सो अगेन यूजिंग द रिलेशन समथिंग लाइक दिस वन, ठीक है, कि initial volume changes from the initial stage to the final stage, we can write the Q is equal to nRT log Vf over Vi, ठीक है। और change in entropy, we do know that it is equal to Q by T, ठीक है। So we will put the value of Q, and then the final relation would be something like this one, ठीक है जी। और then क्या आपके पास 1 mole of gas है, so we will take n is equal to 1, ठीक है। Vf over Vi हमने 2 क्यों लिखा है? Why we have written it as 2?
तो वॉल्यूम दो इंक्रीज हो गया था, इस वजह से 2 गुना, 2 टाइम्स।
डबल हो गया, हाँ डबल हो गया, कि लेट्स सपोज के इनिशियल वॉल्यूम आपका क्या था 40, और डबल होने से क्या मुराद है, इट विल गो 80। सो आपका इनिशियल वॉल्यूम 40, फाइनल वॉल्यूम 80। अगर आप दोनों को डिवाइड करेंगे, मतलब वी एफ ओवर वी आई 80 ओवर 40 करेंगे, तो वैल्यू किसके बराबर आएगी? 2 के बराबर आएगी, ओके। सो दैट्स व्हाई वी हैव रिटन इट एज 2 here. So we will put the just values here, and this would be the net entropy change, which is again positive, ठीक है। So clear हो गया बेटा?
यस सर।
चलें, आज के लिए इतना काफी है, बाकी नेक्स्ट लेक्चर में इंशाल्लाह, नेक्स्ट वेडनेसडे।